coats are thicker than others, but that's one of the conditions to break dormancy, is somehow to get water through that seed coat. And once water goes through, then it activates the endosperm. It's almost like freeze-dried food.
Yeah.
So once the water gets in, that endosperm becomes food for that baby plant. The baby plant starts to grow. It busts through the seed coat and it starts to grow. So that's germination. So you can see in here the endosperm is B. The cotyledon, all that is, and you could make a note of this, is that the cotyledon is the baby leaves that are on that plant. To tell you the truth, I don't know what the coleoptile is. I would have to look it up again, so don't worry about that word, because obviously if I've gotten through my whole career without knowing it, you won't need to. You could look it up if you like. Shoot, of course, is the shoot of the plant, the baby plant. The root is the root of the baby plant. Coleorhiza, I'm not sure about either, so you can forget about that one. And adventitious root is H.
The root is pointed down toward the point of the seed, because that's where the root comes out, right? And then it pushes the whole seed coat up through the dirt, right? Where the
What happens when a seed germinates is it's sitting there, and it doesn't matter which way you have put the seed in.
Yeah.
Because once the root emerges, and the root comes out first, if you can picture a bean seed, you know how a bean has a little mark on it?
It's the belly button.
On one side of it,
Like
that's where the root will emerge. And so once that root emerges, because of the gravitational pull of the earth, what will happen is that root will always pull down. And it will start to grow down. So even if it has to, if it's coming up this way, it'll turn and it'll go down.
Will it automatically push the top upward, or?
And so then what happens after the root is down is that it will push the top up. The top will reach itself up towards the light. And so that's called phototropism, when it reaches towards the light. It's called gravitropism when it's reaching towards gravity. Gravitropism and phototropism. And so because of those characteristics that are inherent in seed, it'll actually turn itself around. And then the what will happen is the cotyledons, or the seed leaves, are trapped inside the seed coat. So it's very crucial that you continue to keep the media moist when seeds are germinating, for two reasons. One is that you have to, once the endosperm soaks up some water, if it stops at any point, the seed will just die. It has to have continual water until the entire endosperm is activated, until the plant sends its root down, that it can access its own water, and until the seed leaves that are stuck inside that seed coat, until the seed coat is softened enough by water that the leaves can bust through that seed coat.
So you should never help the coat come out?
At a point, sometimes you can.
Like if it's holding the tips together like this?
Sometimes it will, but that is a result of your poor monitoring of not keeping it moist enough, right? So yes, you might, sometimes you can break those cotyledons off when you do that, though. Make sure it's really loose before you pull the seed coat off, if you do that, but moisture really helps. So you can see that kind of process in both of these diagrams. Now monocots have single seed leaves, and dicots have two seed leaves. So mono is one, dye is 2, right? So that's pretty straightforward. So plants are classified as either monocots or dicots. Monocots have 1 seed leaf inside with the embryo, dicots have 2 seed leaves. So what are monocots? You can see corn. That's a corn seed. That's a monocot. Corn, all the grains, all the grasses are all monocots. They only have 1 seed leaf. Dicots are pretty well everything else. They'll have 2 seed leaves inside, other than grains and grasses and corn, which is.
You mean okay.
So, the dicot is below, and it will have the 2 seed leaves. So you can follow this process. We'll look at the monocot first. You've got you've got the seed here. All you can see is the seed coat at the moment, right? That's on the outside, it's the seed coat. It's like our skin. Then in the second picture, when you see the sequence of germination here, you can see the root emerging. So you'll see that F is the root. You can see it emerging out of that seed. The seed coat has been softened enough for that root to come out. The endosperm's been activated. And then more and more roots grow first. Why? Because that plant needs water. Water is life. It's already a baby plant, it needs water. And then finally, you'll see in the fourth picture, it's got 4 roots already, and then the shoot starts to emerge. So that's the process that happens. With a monocot, there's only this 1 shoot, so whether it's a grass or it starts out being 1 seed leaf, and that's the way it kind of unfolds, is 1 at a time. If you look at the dicot below, it looks like a bean, and you can see where the root emerges first again, and you can see how it's actually, the root is emerging, and then it pushes that bean out, and then the first leaves unfold. Now the first leaves that come out are called the seed leaves. And that's a really important
It's just saving
concept
energy by keeping the screen
between
off.
seed leaves and true leaves.
Thanks.
So when you look at the picture here, these seed leaves are emerging. And those seed leaves are the leaves that used to be inside. They're the cotyledons and they're the seed leaves. They used to live inside the seed, and now they're emerging. And so, why is this important? Because it's not a good idea to either fertilize or transplant a plant until the second set of leaves emerges. The second set of leaves are called the true leaves, and they will look like the grown-up plant. The seed leaves might just look kind of generic, like it's hard to tell the difference. Sometimes you'll get to know some of them and some of them are different, but it's really hard to ID a plant from the seed leaves because many are very similar looking. But once the second set of leaves, which are the true leaves, emerge, it's a lot easier to identify the plant, and that is also the stage where you can start fertilizing because the plant can actually start to use the food then. When the first seed leaves come out, they're just still working on the endosperm food. So they're working on the food that was in the seed to begin with. And it's only when they start to photosynthesize enough to open the true leaves that the plant can start to use fertilizer. Now, if you put fertilizer to any amount, even too much compost or whatever on the seeds before they open their true leaves, what happens is that the seed flats can develop algae, things like fruit flies and fungus gnats really love to eat the algae. They also love to eat the roots of your plants. So you don't want to start fertilizing or putting anything on the plants too soon before they get their true leaves. Yeah?
Yeah, cause I was doing it wrong, so I was digging the trench, planting, and then topping with my compost, so that's not a good idea.
Once you're out in the garden, it's not as
So
detrimental as
so
if
direct
you're
sowing.
starting things inside in flats. Yeah.
So direct sow is
Yeah, direct sow, you can have it in rich soil because there's so many other factors that are mitigating that. But in a fake environment, you know, which a growing room or under lights or stuff is, you're more likely to get problems because there's no natural controls for them.
Yeah, no predators.
Right, and not as good air circulation, not the intensity of sunlight. It's an artificial environment. So working with artificial environments is slightly different. Thanks for asking that. So the other thing is, once the plant unfolds its true leaves, is a good time to start thinking about transplanting it. So that's really important that you notice that process of unfolding the seed leaves and then the true leaves. Now, what I have here is some colored pencils. And you don't have to. There's lots of different ways to learn this stuff. Some of these might not work. I'm warning you. So there's lots of different ways to learn this stuff. But one of them is to take these things that I have given you and color each one of the things with a different color. So you would color all the seed coats with green, and then all the roots with red. And it would really make it stand out for you if you're a visual person. And it'd be a lot easier. And you could even, you know, color the seed coat, the letters green and then green, so that you could visually right away see it. So that's one way that you can study this. The other way is what I have found useful for me, but it doesn't work for everyone, is to really look at the vocabulary and look up the vocabulary. So get the definitions of these words, you know, so that, you know, you can use them. And again, there's lots of different ways to study this.
You don't want to, if you're talking about it, you don't want to call it, oh, you know that thingy that comes out.
Yeah, exactly. Yeah.
So on the photo here,
Yeah.
H, and the second diagram halfway through is the adventitious root.
Yeah.
But then down in the bottom, on the bean plant, the root that shoots to the right is just labeled root.
Right. And so
Would that, is that a mislabel or?
no,
is that
no,
because it's
they're both roots. They're both basically roots. But adventitious roots are sort of secondary roots
A
that
lateral branch,
branch out.
yeah.
Yeah, that's all. So, yeah, so I'm gonna send that home with you if you wanna take a few colored pencils home, if you wanna do it over lunch. I don't care, you don't have to hand this in.
Like this guy.
Yeah, like that kind. So, you don't have to hand this in, it's just another way for you to look at it and study it, use it whatever way works best for you. So, if we're talking about seeds, I'm a really big fan of saving seeds because I think saving seeds is the key to food security. Because there's so many microclimates everywhere, but especially on this island. I did some research on rainfall in Nanaimo, and there was 6 different rain collection stations. They all had different amounts of rainfall just within the city of Nanaimo. And I'm sure that, you know, you have witnessed in places that you've lived, if you're on a higher elevation, if you're closer to the water, if you're in a little frost pocket, if you're, there's a million different situations that you could run into. Your soil is different. There's so many differences from place to place that over time, it benefits you to think about saving your own seeds, because then it'd be uniquely adapted to whatever is most successful in your soil, in your microclimate, in your area. So
is there like, do plants have like conditional memory where if they're grown in the same condition all the time, when you seed them, they're more adaptable, they're more adapted, well suited for that?
absolutely, absolutely. I'll give you an example of that. We at the college used to grow 4 seedlings, okay, for reforestation, for replanting. Have any of you ever done tree planting? Anyway, oh yeah, me too, me too. And but we used to grow a whole greenhouse full of a couple 100,000, I think we had, 4 seedlings. Now we had a contract to grow for replanting in Prince George. So the seeds from Prince George would not germinate if the days were short. You know how our days get longer, as like from today at 2:28, when spring begins, the days will now be longer, right? It's the equinox now, so the days are the same length. When the days get longer, it will happen later up north, but faster, right? And so what we had to do, growing these seedlings from Prince George, we planted them this time of the year, but the days were too short for Prince George seeds to germinate. Because what would have happened to Prince George seeds if they germinated at this time of year?
Frozen.
They would probably get frozen.
They're still frozen.
They're still frozen. So the only trees that continued to live in Prince George were ones that had seeds that didn't germinate until the days got long. Makes sense, right?
Yeah.
So even if Prince George didn't get snow, you know, you might get a warm day. If the seeds germinated, they'd probably be killed by frost. They're still getting hard frost there. I mean, we had a frost this morning.
So if you did it over generations, they would eventually adapt here and germinate earlier if you did it gradually?
Absolutely. There's a story of a guy in Siberia that is now growing cantaloupe melons.
In Siberia?
In Siberia.
Wow.
He worked 25 years to get them to grow. But you can imagine he's got a great market.
Yeah.
Oh, yeah.
Right?
The only one
Fresh
there.
cantaloupe, yeah.
Yeah. And you know, the first time he just got a little melon this big, but he managed to get a mature seed. And he just kept, the earliest one, kept saving seeds from the earliest, the best, the biggest one. So it is possible by selection. I mean, that's what nature does, is natural selection. It chooses the strongest plants, the best plants. If you just let a kale plant go to seed, or any plant just go to seed, it produces thousands and thousands and thousands of seeds. The strongest ones survive. When you buy a package of seeds, they've collected all those seeds, the weak ones, the strong ones, the medium ones, and they've stuck them all in the packet.
Different phenotypes.
Yeah, they're different phenotypes, exactly. They've got slightly different genetics. They've got the same genes, but they're expressing, the gene expression can be different in every single seed. And so the more you select for the qualities that you want, the trouble is with a lot of commercial varieties, again, they're selected for shipping, they're not selected for taste or for nutrition, or for even insect or disease resistant, because we have pesticides. Why would we bother with that? Right?
Yeah.
So unfortunately, a lot of commercial seeds are not selected for what really would be better for the planet
Right.
and better for us. And if you are growing locally, you don't have to worry about shippability as much. I mean, it might still be a good idea, say, if you're growing beets, to look at ones that store well.
All of them.
You know, or, so, you know, that whatever quality you're looking for. And it could be something completely different from plant to plant. So for spinach, you don't want spinach to go to seed before it forms a big, beautiful plant, right? You want a big spinach. I just got back from New Zealand and they had spinach like this big. I had never seen spinach this big before. I got close in Eucalypt when I was growing. I had a huge spinach plant, but oftentimes the fluctuating temperatures and day lengths will cause spinach to bolt,
Yeah.
right? It goes to seed like very easily. And so you don't want to collect spinach seed from something that bolts really quickly and get all excited, oh, well, I can collect seeds from this. Oh, no, it's a crummy little plant. Why do you want to propagate a crummy little plant? You want to propagate a plant that has grown big, huge leaves, because that's what we can sell.
But if one plant has all different phenotypes, wouldn't a big plant still have weak seeds?
It does, and so that's why it's more than a 1 year process, right? So you keep selecting the best out of every generation.
And eventually,
Selecting the best, and eventually, it'll still have those genetics again, but they'll be in dormant genes rather than expressive genes. So, you still will have some, you'll always have some variability with open pollinated seeds, but they will eventually be more and more of what you want to grow. So it's really kind of cool that you can do that and select your seeds. So we'll just kind of go over this. So this is another way of looking at it. This is a dicot seed. Sometimes the tip of the root is called the radicle. We have the hypocotyl and the cotyledon. The seed leaves, the line doesn't go all the way. And that's all the embryos, that's the baby plant. And the hilum is where the root emerges. So you can see this is sort of where it's going to grow out there. So there's a bunch of different names, but don't worry too much about that as long as you understand the function, that the water soaks through the seed coat, and then it starts to grow, the root grows down. So photosynthesis is what happens when those leaves start emerging. And photosynthesis, actually carbon dioxide and water goes in, and oxygen and carbohydrates, and actually carbon dioxide comes out. So carbon dioxide and water make carbohydrates with a little bit of extra oxygen. And plants can actually recombine, break apart and recombine basic molecules. I mean, humans have a hard time doing that, but plants, every moment that the sun is shining on a plant, it is busting apart the carbon dioxide into carbon and oxygen. It's also taking in hydrogen, and from the water, hydrogen, water is H2O, hydrogen, oxygen. So it's busting the carbon dioxide apart. It's busting the water apart. and then it's recombining it into carbohydrates with it, and a little oxygen gets left out. During respiration, it also will get rid of some carbon dioxide, but then it takes it back in. So plants just basically pull out of thin air and water and make food. So they take air and water and make food.
That's what we do, don't
You know?
And
Thank
light.
you, plants. Yeah.
And light.
Yeah, it needs
Does.
light, yeah. Needs light for the energy. So they're solar powered food makers. So carbohydrates contain the sun energy. Carbs in plants combine carbon dioxide, water, sun energy to form glucose. And plants don't use all this energy stored in their sugars, so it's available for humans. Plants are the first link in the food chain that supports the earth. So not only are plants extra sugars available for humans, plants also have relationships with microorganisms, very close relationships with microorganisms. They actually feed over 50% of the carbohydrates that they manufacture to their community of microbes. Where do those microbes live? On the surface of their leaf, on all their tissues. I mean, if you